Hello everyone, welcome to one more video. This is Daniel Pinheiro from danielpm1982.com. This video is a continuation for another video whose link I'm gonna leave at the description of this current video. And at that video I've shown you how to install Docker and how to use it to run existing Docker images from dockerhub. So in this video what I want to show you is how to create your very first image, including in it, for example, a base existing image for openjdk, Java JDK platform, as well as a Java application that we're gonna create right now. So we're gonna create a Java application, then we'll create the image, we'll build our first Docker image for that application, and later we'll share it at dockerhub by creating a remote repository, and then we'll push the local image we'll have just created to the remote repository. Then we're gonna clear all the images and repositories we have locally in order to prove that we then can download again from the remote repository that same image and run it locally again. So basically we'll create a Java application, then we create a Docker image, and later we'll share that image we've built to a remote repository at dockerhub. So let's start by creating a sample Java file here. So the Java source file we're creating, I'll call hello world.java, and basically it will be a simple Java class with an output of basically a string message hello world. So let's create it here manually with the gedit, which is the text editor by default in Ubuntu. But of course you can create by using any other text editor you want. Okay, so this is all the application source code we're gonna use, and save. Okay, so now we have a hello world.java, which is a source code with pure Java text written inside, and now we gotta compile that source Java code into the hello world.class compiled file. So for that we're gonna use javac or Java compile, and enter. Okay, it has compiled, and we hadn't any compilation problems. So now we not only have the source Java code we had initially, but a compiled code in the hello world.class file. Now next, what we have to do is to create a manifest. If you doesn't know what a manifest is, basically it's a text file that configures some properties for the jar file. You can read better about it at Oracle Java documentation, but basically it's a simple text file that in our case here is simply to set 3 properties you're gonna see now. So let's use again the text editor of Ubuntu, which is gedit. You can use any name for the manifest.txt. So here inside the manifest.txt we simply add or set 3 properties. The manifest version, which I'll leave as 1.0. The created by property, which I'll change to Daniel PM 1982. The organization, danielpm1982.com. Okay, and here the main class, it's the entry point for the jar file that we're going to create next. The main class will be basically the package of the class. We're not using any set of packages here, so we simply have to use the class name without the dot class. So our class is hello world, save. Okay, that's basically it for our manifest. So now not only we have the source code and the compile code, but the manifest we're gonna use along with the class file to create the executable jar file that later we're gonna add or copy to our Docker image. So for creating a jar file, we use the jar command and some properties as C for create file, which is the jar file we're creating, M for specifying the manifest, otherwise it will create a standard manifest that doesn't have the entry point, and the V for showing the outputs in the verbose mode. So now we specify the jar file we're creating. I'll just set it with the same name. Of course, we could use any other name, but I'll just set it as hello world.jar. And for creating this jar, we're going to include the manifest.txt. And lastly, we pass the hello world.class compiled code file. Okay, it's created the jar file. And now if you see, we have the executable jar file, which we can test by using java.jar hello world.jar. Okay, I just forgot to include the line breakers here. I wanted to include some lines here, so I'll just edit again the hello world.java and add here the line breakers /n Okay, we'll just save it, compile it again. And now recreate the jar file from this updated class file with the line breakers. So, okay, and now let's rerun the jar file. Okay, and that's what I wanted to display at the output. Okay, so this is the executable Java file we're gonna copy to our Docker image file in order to turn available this Java simple application for any person who chooses to try our Docker image by cloning it or downloading it, pulling it from the dockerhub and creating any number of containers and running or starting that containers for executing this application. And as you see, we'll also at the Docker image, we'll also use openjdk so that the person won't have to have Java installed at his system. In our case, we have Java installed, but the person that's gonna use the Docker image won't have to have this dependency installed in his file system because he's gonna use simply the Docker image and create a Docker container that will automatically include all necessary dependencies for running this application, which in this case is the JDK and GRE Java applications. Okay, now that we have the jar file, the next step for creating our Docker image is to create our Docker file, txt file. So for that, I'm also using gedit dockerfile.txt, and at the Docker file, we're going to include the following commands. You can read about the commands you can use here at the Dockerfile kind of script at the documentation for Docker. So if you go at the documentation, develop with Docker, build images, Dockerfile best practice, you find this guide from Docker, and here you'll find all the possible commands or the main commands that we can use for creating our Docker file and later build our Docker image. So we have the from command, we have the label, we have the run, we have the cmd, we have the expose, we have the env, we have the add or copy. We're gonna use the copy. We have the entry point, the volume, user, workdir, and on build. So what we're gonna use basically here are the commands from, which sets the Docker image, the base Docker image that we're gonna start from. So we are extending this existing Docker hub image. It started from it as a base image and extending it with the other commands we're gonna add here next. So if you go to Docker hub and look for openjdk, you find this official image, and for this official image you have here all the basic documentation for it, as well as the tags that you're gonna use for each version. So we're gonna use the openjdk as the image name, column, the 18 tag for the 18 version of it. So we're gonna use openjdk column 18 as the base image. And extending it, we're gonna add the rest of the script here at the creation of the image. So next, other than the front, we're gonna use the workdir, which basically sets the working directory. We're gonna use here the slash for simply setting the root directory of the volume of that container as the working directory. Next, we're gonna copy the local file system jar file that we have here at our temp directory to the root directory or working directory here at the image, and later to its containers, also to a file there named helloworld.jar. Of course, you could rename this for any other name you wanted, but I'll just keep the same name that we have here at the local file system. So we'll copy this local file system jar file to the root working directory of each container created from the image we created. And finally, we simply execute the Java jar command over the copied jar file helloworld.jar that we have copied to the container. So in short, at the dockerfile.txt, which is the Docker file we're going to use to create our Docker image, we set the openjdk column 18 as the existing dockerhub image we are going to start from. Later we set the work directory as the root directory of any container created from that image. Next, we set the script of the image here to copy the helloworld.jar that we've just created to each container root directory or working directory. So any container created from the image we are creating will have the helloworld.jar, which is the same or a copy from the helloworld.jar from our local file system here. And finally, we simply execute this command again, but this time from inside any container created from the Docker image we created. So the command will be the java-jar helloworld.jar. So this is the whole script for our Docker file. Let's save it. I forgot to create the Docker file at the temp folder, so let me just move it there. Docker file to temp. cd temp. Okay, so now we have the only resource we're gonna need as our application, which is the helloworld.jar. And we have the dockerfile.txt, which is the archetype or blueprint for our Docker image creation. And now the only thing we're gonna need is to use sudo docker build -t and the name of the image that we are creating, which I'm gonna call simply hello. Okay, here I have made a mistake. The Docker file must not have any extension, so I'll rename it to simply Dockerfile and not dockerfile.txt. So mv dockerfile.txt dockerfile. Okay, so now we have the jar file, which is our application, and we have the Docker file with the script needed for Docker to run the image creation. So now we just use the following command: sudo docker build -t from tag and the name of the Docker image, which will be simply hello world, for example, and the directory where the Docker file should be found, which in this case is the same directory here. And we can simply add a point here. The point representing our current folder. So enter. As you see, it's downloading or cloning the openjdk tag version we specified as the starting base image, and it's using the rest of the script for creating our hello world Docker image. So the image has been built and has been successfully tagged as hello world, and by default the tag is set as latest. We now can use, for example, sudo docker images to see the images we have at our file system. And here we have the Docker image we've just created about a minute ago with a size of 474 megabytes. This is the image ID. This is the default tag, as we didn't specify any specific tag or version. And this is the image name, hello world without the dash. I also had some other images here at my file system, the openjdk. Actually, this openjdk Docker has downloaded in order to create the hello world, because it has been used as the base image for the creation of our hello world image, which is an extension of this openjdk image. We needed to have Java available at the image or at each repository created from our image in order to run our application. So our image would have to include not only our application, but as a base image, any image containing the Java platform. So we use the openjdk version 18 as the base platform and extended it with the other script commands at our Dockerfile. And these other two images have nothing to do with what we've done at this video. These are simply old images I had already downloaded at my machine. Okay, so now for testing if our Docker image is okay, we'll simply ask Docker to run it. And by running it, we already know that it's going to create a container from that image we've just created, which is this one, hello world. We can use the image ID or the image name. Let me use here the ID, and we simply call sudo docker run. You can use the ID and the image ID or the image name. So enter. And there it is, our java.jar application running from inside a Docker container created from this Docker image we've just created. And remember that even if we hadn't Java installed at the operating system we have, it would still be possible to run that image because all the dependencies, including the Java platform needed in order to run our .jar application, is inside any container created from this image hello world. So any container created from this image will not only include our .jar application, but a copy of the openjdk platform version 18. So the only thing needed from the eventual user of this Docker image would be the Docker platform itself. You would have to install Docker and ask to run this image, either from what already he had locally or from any registry remote repository. In our case, we're gonna share it or upload it to dockerhub next, so that anyone can ask to run it from dockerhub and execute this application here. So now we want to share this image we've just created with Docker community by uploading it or pushing it to a repository at dockerhub. So the first thing we gotta do is go to dockerhub. You just sign up here first and later you can sign in. I already have my account here, so I'll just sign in. Okay, now I'm at my account here. If you see here, there's my profile. I don't have any repositories here yet. Actually, I have erased them. But what we first gotta create now is a repository. So you can go here, repositories, at the navigation bar, repositories. If you see here, you are logged to our account. Now you can create a new repository. The account's name is the namespace, and you can create a repository here very easily. So as the name for the repository, I'll simply use hello world. And next, after we create the repository, we'll push the image we created to this hello world repository here. So let's create. Okay, Daniel PM 1982 / hello world. This is a brand new repository. And now what we have to do is go back to the console and use sudo docker login, and then you complete with your username and password, so that now we are logged. Next, sudo docker pull. We're gonna pull our repository hello world. Okay, with no /, only the repository name. The repository we created there at dockerhub was hello world, hello-world. So now we've pulled that repository here. Now, for pushing our created Docker image to the repository, just use sudo docker push and the name of the image, which is hello world latest. Requested access to the resources denied. Okay, and this is because we have not yet tagged our Docker image to our repository yet. So for that, you should use sudo docker tag the image name or image ID in the repository. Then UPM 1982 is the namespace / the name of the repository is hello-world. Okay, and now let's try to push again, but this time using the tag Daniel PM 1982 / hello-world. Okay, so now it's gonna take the Docker image and we'll use the tag of that image. Observe here that the image ID is the same, both for the Docker image as for the tag. And now that the image is tagged to the repository, it will access that repository, remote repository, and push our image. So enter. Now it's pushing. And it's done. So now let's go to our Docker page and let's see at my repository here, at my remote repository. Let's do a refresh to see what Docker images are now available here. Okay, so now we have here our first Docker image pushed to our remote repository at my account. And for testing it, let's go back to the console and I'm gonna exclude all the Docker images I have here locally. so that we can test to run this now remote Docker image we just created and pushed to this remote repository and see if it works as it worked when we ran it soon after we created it locally. So let me go back to the console. So for removing all the containers and images available locally, as well as their volumes, we can use sudo docker system prune -all. This will remove all the stopped containers, all networks not used by at least one container, all images without at least one container associated to them, and all build cache. Yes. Okay, everything is cleared. And now we can check sudo docker images. There are none. Sudo docker ps-a. There are no containers as well. So now what I want to do is to use sudo docker run and use the path here of the image we've just pushed to this remote repository of mine. Daniel PM 1982 is the namespace and the hello world is the remote repository. So we gotta use this full address. And the tag name will be latest. So that Docker will search at this namespace, which is the namespace of my account. Also inside this remote repository hello world, and inside this repository it's gonna search for this tag here, the latest tag. So it will access this image through its latest tag inside this remote repository, inside in turn this namespace. Enter. So it didn't find locally this image, and now it's downloading or pulling all dependencies from the base image and later from the image itself, and then it's going to create a container from this image, and then it runs the container. Okay, so now we have used the command sudo docker images. We have this unique image here present locally, and we have this container created from the execution of this image. So in this case, in the case of this container that basically outputs a Java string, in case you wanna run it again, you should remove the container and run the image again so that you can see the output of the Java application showing again. Because if you just try to start this again, it will start but won't show anything. So if you just remove it and later run again, it will take the image already present locally. It won't pull again from the Docker hub, and it will create another container and simply will run the container again. But just have in mind that for each running of any image, it will create one more container. So I've run it 2 times, so it created 2 more containers from the same image. But we can clear everything again, so with sudo docker system prune /a, and now all containers and images have been untagged and deleted from our local system. But of course, it's still available. If we refresh here, it is still available at our remote repository at this namespace linked to my account. So we could push any number of new images with different tags here for the same repository, and anyone who wished to use it would simply run again by calling the namespace / the repository name column the tag of the image you wanted. So I hope you have liked this video, and there are many videos yet to come, so see you in the next video.